Okay, hello everyone. I am Aqsa Awan and today I am going to present the article titled as a Single Cell Assist, an AI-based workflow assistant for single cell analysis. So let's start by reading the abstract. Is everybody done? So what do you think is the first sentence?
First one.
First.
Because it mentions the reason why they are doing this. So, as we know that single cell analysis involves a lot of steps, and the workflow is kind of complex and requires a lot of speciality and expertise. So, some of these steps for the single cell data analysis involve quality control analysis, normalization, and also dimension reduction and clustering. So in order to perform this analysis, a person should have a lot of expertise to be able to select the appropriate parameters. So this standard workflow requires extensive knowledge, expertise, and time. So is there any way we can reduce this? So recently we have been seeing that LLMs have been applied to various fields. So they are playing a huge role in research, education, and personal care. So can we use LLMs to streamline this complex single-cell RNA sequence analysis workflow? So in this paper, the authors combined LLMs with R to create a single-cell assist. So basically, what is single-cell assist? It is an LLM-powered assistant that streamlines single-cell analysis within the standard Surat workflows. Surat workflow is basically an R-based workflow that is used for single-cell analysis. So they simply streamline the LLMs in this workflow. This is the architecture of the LLM powered assistant. So first top part is that these are the typical steps that involve normalization, dimension reduction, clustering, and all those steps. So what they did is these pink colored boxes are the single cell assist functions, and they tried to incorporate it into the steps, and then they use the LLMs to derive the insights and ask the LLMs to give them the best parameter that can be used for the next step. So most of the functions have almost similar architecture, so I will explain the basic architecture of how the single cell assist function works. So basically it takes the Surat object as the input because it is using the Surat package for workflow. So Surat object is, if anyone doesn't know, it is a kind of data structure that is used in R to save the single cell related information, and it saves all kind of results. Like if we go with the flow, it saves every step's output in it. So after inputting the Surat input or Surat results in some cases, the workflow derives some data or matrices like matrices, and what here now how LLMs do is that they have already designed a prompt template, and they kind of populate the data matrices or the results with this prompt template, and then they make an augmented prompt that goes into the LLMs. And this prompt is as an input to LLMs. On the basis of this, LLM will decide or give the recommendations. And this includes the prompt and what they want to do in this, and the data or the matrices from the previous results. So let's see here, if a person wants to say that I want to determine the refined cutoff values that are sensitive to this and this, and then they can just provide what they want to do. So LLM will provide them the output, and it will be detailed explaining each and every step. Like here, they recommend that you should use this range cutoffs for the income to RNA and the number of features. So after performing this analysis, they wanted to check how well LLM's results are.
Aqsa.
Yeah.
Should go to the previous.
Yeah.
So augmented prompt, how do we create? Do we create augmented prompt?
No, it's actually happening from here. Like they combine using this. Nothing is happening by the user. They have already made the prompts that provide better results, so it is already in their package.
In their package?
Yeah, so they just put the data matrices or the results that they obtain into these prompts. Every function has different prompts.
So you mean this package automatically generates the prompt?
Yes,
Or-
they have already.
Okay. So then what usually need to prepare is just Sarah.
Yeah, so they have to just like they have to provide the command in R, like to run that specific step.
Also they provide data, run some command,
Yeah.
then it automatically analyze with Sarah, and with this data
And
it generates the prompt and it automatically plug in
yeah,
that things that the whole thing with
and yeah,
and it ends with this result.
yes. So here then it can also generate the select object that will also be used for the input for the next step. So this is the like basic how the functions will work, and most of them are the same. Like, this is the basic logic behind the functions.
And what Surat object, is it just tabular data?
No, it's a data structure, and it has different kinds of data. So it's actually a R-based data structure, and it can contain any kind of data related to single cell or RNA or genes. So it can have like graphical data, and it is kind of like we can think of it as a container that can contain like every version of the analysis that we are doing, and it can access the information from that too.
Maybe we need
Yeah.
but he's not here.
Does it mean it just produces a lot of information after you type the command? So you, for example, I just want one answer to one question.
Yeah.
Is it possible?
Like
I just want an answer to a specific question.
like a specific step or like whole.
No, just a specific step.
I don't think so. They have that.
Or it just outputs everything.
So it's kind of like, yeah, for that step, it gives the reasoning that for the parameters that goes in to the next step. So it kind of gives the information because we can't really enter anything. The prompt is already there.
Oh, okay. So you can make your own prompt.
Yeah.
So although the prompt is fixed, but since LLM gives different answers for each trial, so maybe the parameters can be changed, is it right? Type of parameters?
Yeah, they also mention it in limitations. If the model has like different changes, then it can change.
But if you go to the Surat object side, it seems to me everything is numbers, no?
No, there can be any kind of data. It is just an example.
Did they mention how they build these prompts?
So they tried a lot with these, and then they came up with these prompts that are more like useful or the best in producing the results.
Okay.
Because prompt is really important in LLMs.
Yeah.
These are the, like they mentioned, optimized prompt. So then they checked how well this is producing the results. So they measured the groundedness. So what is groundedness? They tried to measure how LLM's results were different from the original results. So they tried to compare it because LLMs can hallucinate, like they can produce wrong results. So they created the ground truth that was based on the validated reference set of results, and then the LLMs is the response from single cell assist, and they got the intersection of the two and then divided it with the LLM's response. So when they checked it on with this data lymphocytic choriomagnetizing virus, they got that it had average of 98.70. That it means like 98% of time the results were same as that of the original.
So what is ground truth?
So it is basically just checking how well LLM is predicting the results, and it is not hallucinating. That is what they mention in the articles. It is kind of, so they used a gene man, and they like if they got the gene results from, so they will be getting two sets of gene groups. That will be the ground truth, and one will be the LLM. So they intersected and they drew the Venn diagram, and if they overlap, then they were produced, they will put here because they are the same. So they performed this on two data sets, and the results were almost the same.
What does that token mean in input token?
So it is like just the input from the ground truth. It is just like a general term for the token. It can be anything, like it can be genes, and they just name it as like input tokens.
But the ground score, groundedness score 100%. It's a bit suspicious.
So, isn't it like that? For example, that enriched terms. I don't know what they are, but the GT intersect LLM is so much smaller than GT, but still the score is so high.
높아질 수밖에 없죠. 지금 심판이 2인 거다 하니까 GT를
so the goal is not correctly predicting or following GT.
Yeah, because it is like we can say standard with which we are going to compare it. So when, for example, let's think that we have performed an analysis and in the end we have to get a specific number of genes.
Which number of genes?
So let's say we have a specific set of genes. So first they performed it with ground truth, means that it is the verified results. So it will have a set of genes, and then if we run a single cell assist, then LLMs, following the LLM's recommendation, we will also get a set of genes. So then they compared how well these results matched.
So, for example, the enriched terms case, LLM only yield 53 genes,
Yeah.
while the ground truth is 3,000 genes.
It is actually, the tokens is not,
Not gene.
yeah, it's kind of like that LLM token. How to, it's kind of hard to explain.
So then why you put GT in?
Oh, there is something wrong with it.
And I don't get it. Why we should put the cardinality of LLM within a measure.
Yeah, I get it, but I know that I'm looking at it, it kind of look weird. But they just wanted to check whether it is hallucinating or not. So,
Hallucinating.
so it's like hallucinating is like if an LLM gives a result that is actually wrong, but it seems okay.
Okay.
peg graded.
So they wanted to check that.
GT가 뭐야 맞아?
그게 So then denominator is the number of total sum reported by
They mentioned LLM, yeah.
that
So,
and
Yeah,
among them what is the not hallucinating.
yeah. So it's kind of like what is the true result that it is producing?
Oh, okay. Yeah, so it's complicated
It's
because
kind of-
we put GT in the input because it's
Yeah, so-
complicated.
Do you have any opinion why variance explained the low score?
It's because like in case of LLMs we can't really know because it's like a black box. We can't really explain why it would.
So maybe the other variables are some categorical variables. Experience explained is kind of continuous variable.
So maybe that
Maybe
could be
yeah.
them.
Okay.
So for the other tests, they used the researchers to check the reports that were made by the single cell assist. So they tried to check whether the experts are really happy with the results that single cell assist produced. So they used the like it's scaled from 1 to 5, and they provided them with a survey, and they filled it. And the result, as we can see, accuracy is that how much they think the results are accurate, and for relevance, how much they think that it was relevant to the questions. And then clarity was like how much the results were understandable and clear. And for trustworthiness, that how much they can trust the results that were produced, and their overall satisfaction.
So how many researchers take this survey to this record scale survey?
So there were 8 researchers actually,
Mm.
and 8 researchers.
8?
Only 8?
Yeah. So 2 of them are already like the author of this paper. So there were like 4 junior researchers and like 4 experts. So
Should they have mentioned the names of the researchers?
no, they didn't mention the name, but I think they mentioned their
Contribution.
designation.
그런 건 처음 봐.
바이오인포메틱스는
나쁘진 않고. 괜찮다. 좋은 일도 좋은 데지.
So they just mentioned that the senior scientists were from 2 were from biotech industry, and 2 scientists were from NIH, and 4 junior level ones were just the postdoctoral fellow at NIH.
그렇게까지 높진 않아.
Did they compare with another alternative method?
So they used another semantic, like they just checked the contextual relevance, not any other.
So we can't evaluate how improve this method. I think comparison is required to show this advantage. It's not my opinion.
The key contribution of the authors is just well organized the print. Is it right?
Yeah, we can kind of say that because I think they were already experts, so they already had the workflow.
Okay.
So they just tried to make it more easy and
음, so they make this whole process easy, right?
That's the main.
With contribution.
yeah, because like the previous methods where they used LLMs were just for specific functions, not for the whole workflow. So they kind of wanted to make it more easy.
I see their GitHub, and I think they really easily implemented in the R,
Yeah,
and also powered by LLM.
yeah.
We sense how to improve this methodology. It's just making some easy to use pipeline.
Yeah, so in the future they actually want to make it more automated. So that is one thing that they mentioned as the future direction.
Oh, did they use their own LLM, or did they just bring some packages or?
So they mentioned that a user can choose what they want to work with. So they will have to mention the API, and they can just use any LLM they want.
Did they mention any time taking to
No. So they just mentioned that LLM's report had the highest quality. Like it was easy to understand the reports that were produced by LLMs. So,
But I wonder what is so special in using R. Is it because I don't know R?
because I think they wanted to automate the Surat workflow. It's
For R.
yeah, it's in it's an R package. So it is specifically for single cell data analysis.
Will you recommend this to Yankin? Yes or no?
Or he can give it a try whether it works well or not. That's all.